Hello, in this video I'm going to demonstrate how to do loose coupling between an application and its components, or what are called dependents. For example, we have an application called program01 here, and in this particular program I want to make use of this product DAO, which provides me some operations such as getting a product, saving a product, or updating a product, or delete a product. Now, I have a default implementation called as product DAO file IMPL. If I open that, you can see that the class implements the product DAO and has all the methods being overridden here. However, I do not have any valid code in that, but just to give some output, I have a print statement here saying getting product from a file, or saving, or updating, or deleting a product from file. Now let us see if we can use this in our program. So when I go to our program and let's say add a main function, we would like to work with product DAO file IMPL, but we would like to make use of the interface. So I'll say here product DAO. To get an object, we will say DAO equals to new product DAO file IMPL, and that gets me an object. However, this is currently called as a tight coupling. Now, why is it called tight coupling? Because this application needs this particular class. Now, tomorrow, if we implement this particular interface using JDBC, that is databases, then I have to come back to this particular source code and manually make those changes. Now, also, we would like to get this at the runtime depending on some choice from the user. So let's see how to do this, but first we will finish this program and execute this. So now that I have DAO object, I can make use of DAO dot get product with some ID, probably DAO dot delete product with some other ID, or even for that matter, I can say product P equals to new product, and then I can say DAO dot save product P. Now, if I execute this code now, you will see that the output will print messages that indicates that it is working with the file. Now, let us say we want now to change this tight coupling to loose coupling. For this, I'll take up another program and then add a main, and then I'll create a product DAO, but instead of assigning an object directly, I would like to get it indirectly with the help of some other class. Now there are two ways to do. One is I can go on creating those classes and then make use of that here. Or with Eclipse, we can follow top-down approach where we define what is that we want and Eclipse will start creating the classes for us. For example, I'll say DAO equals to product DAO dot, or probably I'll say DAO factory dot get product DAO. Now note that there is no such class or interface called DAO factory, and obviously there is no such method as well. So if I move the mouse on this particular class or on this particular code, then I would get some suggestion from Eclipse saying that create a class called DAO factory or create a constant called DAO factory and so on. Now I would like to go with create a class called DAO factory. It'll ask me where do I want. I can change the package to DAO because that makes more sense. And then I just say OK, finish. Now it has created a class called DAO factory, but the error is now shifted to the function because in this class there is no such function. Also notice that Eclipse can make out that we are actually calling that particular function using a class name. So this is supposed to be a static function. And the return value is of this DAO type because we are assigning to that. So if I move the mouse, it says that create a method called getProductDAO in the type DAO factory. And that creates a public static product DAO getProductDAO. I'll press enter to come out of this. Now, instead of return null, I can say return new product DAO file IMPL. I'll save it, and you can see in my program, I do not have any dependency on the file implementation. However, at the runtime, there is definitely a requirement of implementation, but at the compile time, my application does not depend on this. So this is called loose coupling. Now I can make use of those functions which we did here. So I can call all these functions in program 2 and execute that, and I get the same output. Now this way we have used some class and a method of that to get an object instead of we creating that object. Now this also can be used to supply some discriminator here and then get a different object. For example, I'll copy this product DAO file impl.java into product DAO JDBC IMPL and then make appropriate changes, saying that getting data from a database table. And now if I execute this, it is still getting me the older one, but I would like to switch from file to probably a database. Now the discriminator I can supply over here and make the decision in the DAO factory. Do I have to return a product DAO file IMPL or JDBC IMPL? So I can go to program 2 and add that string something like file. Now notice that the method does not take argument there, so that is giving an error. But Eclipse provides an option that says that now change the method into add parameter string. So when I do that, you can see it goes here, adds a parameter string. I'll call it as probably a type to indicate what type of implementation we want. And I'll check here if type dot equals ignore case of file, return this particular object. Now otherwise probably I can also make use of an else if type dot equals ignore case of JDBC, then probably return new product DAO JDBC IMPL. Now else return null in case if the user has given something that we don't have, and that is decided over here. So now I can go back to this, execute this with a file. I still get the same output, but if I change this discriminator to JDBC in uppercase, lowercase, or doesn't matter, now you will see that we are able to get a different implementation. So this actually tells us a couple of things. Number one, how do we do loose coupling? Number two, that we are doing a polymorphism because the same function when we called in the previous example, it was working with files and now it is supposed to work with databases. So thus, loose coupling helps us build applications that are less dependent on each other.